Hi everyone, Pete here, and welcome to this video about negative and fractional indices. In this video we'll talk about how negative and fractional indices work, how to combine them, and how to simplify expressions containing them. In this video we'll also be using the rules of indices, which I explain in another video that will be linked down in the description below. Let's take a look at a negative index to begin with. I'm going to start off by writing down 2 to the power of 1. Above this I'm going to write 2 to the power of 2, and you can see that as I go up, I'm adding 1 to the power each time. So what I can do here is write down the corresponding worked out number for each of these cases. So at the top I would have 16, 8, 4, and 2. So we can see on the left that each time as I subtract 1 from the power, on the right hand side what I'm doing is dividing by 2. Now this of course should make sense because every time I add 1 to the power I'm multiplying by an extra 2. So subtracting 1 means dividing by 2. We can continue this pattern downwards and subtract 1 away from this power here, which would leave me with 2 to the power of 0, and if I subtract 1 again, I would get 2 to the power of minus 1, and if I subtract 1 again, I would have 2 to the power of minus 2. So we're going to keep going on the right hand side as well. So we're going to divide by 2 here, which would leave us with 1. We're going to divide by 2 here, which would leave us with a half. And finally we divide by 2 again, and a half divided by 2 is 1 over 4. So we can see that the pattern continues even into the negative indices. And now it's our job to try and figure out what the negative index actually means. We can see that there seems to be some sort of correlation between the denominator of our 2 worked out numbers from the negative indices and the numbers from our whole number positive indices. So we can pick out a pair here. We can pick out 2 to the power of 1 and 2 to the power of minus 1. We can see that what has happened, going from 2 to 1 over 2, is we have found the reciprocal. The reciprocal is like flipping a fraction upside down. For example, if you had a over b, your fraction would become b over a. So here, my fraction to begin with was 2 over 1. Of course, we don't normally write that one. And then we're going to flip it, and it will become 1 over 2. If we pick out another pair, we can see that 2 to the power of 2, which is 4, and 2 to the power of minus 2 are also the reciprocal of each other. So the general rule that we can learn from this pattern that we've created is that whenever we have a minus sign, that minus sign finds us the reciprocal. So when we have a to the power of minus 1, what we will find is 1 over a. So what happens when this negative number is not just 1? If it's just 1, we can see that we just find the reciprocal. But what happens if it's a to the power of minus x? Well, we can see that this number at the bottom of this fraction is just in fact 2 raised to the power of 2, and then we found the reciprocal of 4. So a to the power of minus x is 1 over a to the power of x. So we can see that these are the general rules for negative indices. And you should try your best to remember these because we'll be using them later, and you will definitely need to remember them for your exam as well. Next, we'll be having a look at fractional indices. To think about this, we're going to first think about squaring a number to create 2. So I'm going to put on the right-hand side, my expression is going to be equal to 2, and I'm going to have 2 unknown numbers. I'm going to represent those with squares. They're going to be times together to equal 2. I've drawn both of these unknown numbers as squares because I want these 2 numbers to be the exact same value. So which 2 numbers of the exact same value multiply together equal 2? Another way to write this expression would be to have our unknown number squared, which is equal to 2. So I know that what I can do is square root both sides, telling me that my unknown number is actually the square root of 2. So let me write down what I found. The square root of 2 times the square root of 2 equals 2, and this doesn't seem like anything groundbreaking so far. There's not even any indices on my page yet. But let's just think about the power of 2 on the right-hand side. Well, it's just 2 by itself, so it must be 2 to the power of 1. So from last video, if we remember our multiplication rule, if we had a to the power of x times a to the power of y, it would give us a to the power of x plus y. So on the left, I would like 2 as the number at the bottom, because on the right, I would like 2 as the number on the bottom. On the left, my numbers are going to be times together, and now I need to think about how I can add together 2 indices to give me 1 on the right-hand side. Now, of course, the 2 numbers that are the same, that add up to be 1, are a half. We can check that this is correct by doing a half plus a half equals 1. We can see that it follows this multiplication rule that we found last lesson. What this shows us is, of course, that this power here, 2 to the power of a half, must be equivalent to what we had before, which is the square root of 2. So whenever we have a power of a half, we've found that that must be equal to the square root of 2. In other words, the power of a half is the same thing as finding the square root. So a to the power of a half is just going to be the square root of a. We can now try this with 3 numbers. So instead of the 2 numbers that we had before, I'm now going to have 3 numbers multiplied together that are equal to 2. So I know that if I was trying to find one of these unknown numbers, I would have to cube root 2. So I would have the cube root of 2 multiplied by the cube root of 2 multiplied by the cube root of 2. So remember, cube rooting finds me the number that when multiplied together 3 times, so the number itself times itself times itself again, would equal the number inside the cube root. So the cube root of 2 times itself 3 times is equal to 2. Of course, on the right-hand side, I have 2 to the power of 1, and what I'm looking for is 3 indices above my 2's on this side that add together to be 1, while also all of these indices being the same number. Of course, there's only one choice here, and that number must be 1 over 3. 1 over 3 plus 1 over 3 plus 1 over 3 equals 1, so we can see that cube rooting is equivalent to the power of 1 over 3. So if I had a to the power of 1 over 3, I would be finding the cube root of a. So before we also found that a to the power of a half was the square root of a. Now the square root has this 2 up here that we choose to not write normally because the square root is much more common. But we can see a pattern already. When we have 1 over a number, we are finding that numberth root of a. So for example, if I had a to the power of 1 over 4, I would be finding the 4th root of a. So the general rule exists, a to the power of 1 over x is equal to finding the xth root of a. So whatever that number on the bottom of that fraction is, we're finding the number that when multiplied together that many times gives me a. So again, try and remember this rule because we will be using it later, and also you will not be given this when it comes to exams. Let's quickly take a look at some examples that use the rules that we have learnt so far. To begin with, we have 2 to the power of minus 3. Looking back at the rules, I can see that a to the power of minus x just finds me the reciprocal and places a to the power of x as the denominator of my fraction. So for this example here, I would be doing 1 over 2 to the power of 3, which would give me 1 over 8. For the second example, I can see that I have 16 to the power of a half. A half, of course, is equivalent to finding the square root. So what I would be doing is square rooting 16, which when we work out would be 4. On the right-hand side, I'm doing the power of a third. So the power of a third is the third root. So the third root of 27, that's like asking what number times together 3 times would be 27. And that number, of course, is 3. Here we're going to look at more complicated indices. And I'll teach you a method that is pretty foolproof that we can use to simplify and work out these problems here. Let's take a look at part A. So we've got 27 to the power of 2 over 3. Now, nowhere do I have a rule that helps me figure out what the power of 2 over 3 means. However, thinking back to the last lesson, and if we remember the multiplication rule, which I'll now write up here, we had a to the power of x, all to the power of y, was the same thing as a to the power of x times by y. What that means is we can split up a power into two things multiplied together, and it won't change the overall meaning of the expression. For example, 2 over 3 can be split up into 2 multiplied by 1 over 3. We're aiming to split it up into a whole number and a fraction with 1 as the numerator. And the reason for doing so is that we know what both of those mean as indices on top of our number. What the expression would now look like is 27 to the power of 2 times by a third. We can see, however, using the multiplication rule, I could choose to do one of those powers first, and then, after working out that solution, apply the second power. In this case, it would be easier for me to apply the power of a third to begin with. I would then place brackets around this and apply the power of 2. Applying the power of a third would give me 3, which I would then apply the power of 2 to. 3 to the power of 2, of course, being 9. So you can see that instead of just looking at 2 over 3, I split up that index into more easy to work out indices. Let's take a look at part B. So again, I'm going to process this complicated index at the top. This time, I'm going to split it into -1 times by 3 times by 1 over 4. I could have split this into -3 times 1 over 4. However, I like to bring the minus sign out as a -1 multiplied in. The reason I do this is because it's much easier to just flip a fraction to find the reciprocal, rather than having to work out another power as you're going through this step. So remember, when I just apply -1, all I'm doing is flipping my fraction over to find the reciprocal. One tip that I can give is that most of these questions will enable you to do the fractional index to begin with. This will simplify the numbers and make them smaller so that the question is easier to work through. So in this case, I'm going to apply the power of 1 over 4 to begin with. Then I'm going to apply the power of 3, and finally I'll apply the power of -1 in order to find the reciprocal. The power of 1 over 4 is the fourth root, so that would be 2, because 4 2's times together equals 16. I would then be applying the power of 3 to that, and then the power of -1. I'm not writing the brackets here because it would look a bit messy and complicated. Just remember to work through these indices one at a time. So 2 to the power of 3 would give me 8. I would then apply the power of -1 to it, which finds me just the reciprocal, which of course is 1 over 8. So whenever you get complicated indices with multiple components, for example here we had -3 over 4 that could be split up into 3 components, -1 times by 3 times by 1 over 4. We want to split up that index and then work through it step by step. Let's take a look at these 3 examples here. For part A, we can see that we can split the index -1 over 2 into -1 times by 1 over 2. I don't have to do this, I could just do the reciprocal and then square root in the same step, but I think that splitting up -1 over 2 into -1 times by a half simplifies the problem. I can apply these one at a time to this fraction. So what I'm going to do is apply the half first, and then the -1. Applying the half square roots this expression. So square root of the top would be a, and the square root of the bottom would be b squared. I now have to process the power of -1, So that just finds me the reciprocal, so I just flip the fraction over, so b squared is now the numerator, and a is the denominator. Let's now have a look at part b. So we can see that power of 1/3 is going to be split up into the power of -1 and the power of 1/3. So I'm going to do the power of 1/3 first, and then the power of -1. Then timesing by 9 to the power of 3/2, so I'm going to apply a half first, and then the 3 afterwards. So you can see that I'm splitting up both of those indices, working out the fractional part first, and then applying what's left. So 27 to the power of 1/3 is the third root of 27, which is 3, and then we've got the power of -1. Then I have 9 to the power of 1/2, which is the square root of 9, which is also 3, and then I'm going to have the power of 3. Power of -1 is just the reciprocal, so I'm going to have 1/3 multiplied by 3 to the power of 3, which is 27. So for my answer, I would have 27/3, but I could simplify before by cancelling out a 3 here and a 3 here, which would leave me with 9. So the final answer would be 1 times 9, which is just 9. Finally, for part C, these expressions are slightly more complicated, but again, we're going to process them one step at a time. For 4/25, I'm first going to apply a half, followed by 3, followed by -1. Those three numbers, of course, times together give me -3/2. I'm then going to divide by 8/27. I'm going to apply the power of 1/3 first, and then the power of -1, which is just going to find the reciprocal. Of course, -1 times 1/3 is -1/3. Let's process those one step at a time. The power of 1/2 is just going to square root this fraction, leaving me with 2/5 to the power of 3, and then to the power of -1. I'm going to divide that by 8/27 to the power of 1/3. The power of 1/3 is going to be the third root, or the cube root. That's going to be 2/3, which is then going to be raised to the power of -1. Let's apply the next index now. So the power of 3 on this fraction on the left is going to find me 8/125. And we've still got that power of -1 to think about. And I'm going to divide that by 2/3 to the power of -1, which is just going to find the reciprocal, so 3/2. On the left-hand side, I have the power of -1, which is going to find the reciprocal, so 125/8 divided by 3/2. Now, dividing by a fraction is the same thing as multiplying by its reciprocal. So I'd multiply by 2/3. Now, before I multiply, I can also cancel out another 2 by dividing by 2 here to give me 4, and dividing by 2 here to give me 1. So the final answer is 125/12. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comments section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.